Hello. Today we are going to see another thing that disqualifies Microsoft SQL Server from being a good relational database management system, as you might have believed until now. Let's speak about triggers. This is the first part about the triggers, because we will also see a second part related to how triggers are, um, let's say, safe to error trapping mechanisms. But today we are going to speak about how triggers are identifying the modified rows. We will have a simple case of triggers on update, and we will compare triggers on Microsoft SQL Server and on Postgres. Let me tell you that on Postgres we will see the same behavior that Oracle has. So I haven't added an example for Oracle as well, because there is no need to do that. First of all, let's look at Microsoft SQL Server. We have created a very simple trigger which fires after an update operation and which select rows in the pseudo inserted table and rows into the pseudo table named deleted. That way we will try to understand how we can do a log of this. For the table supporting this behavior, we do have one table which is called test triggers, which has two columns, ID and val, which stands for value, but it's a short name. ID being a primary key. ID being a primary key on this table. Let's look a little at the table. You can see unique keys. We have a primary key on ID, indeed, and we have these columns, which are ID and value. Okay. The same thing will be present for Postgres as well. Now, let's see the script. We are going to insert into test triggers 5 values, 1, 2, 3, 4, and 5. And we will have a corresponding val1, val2, val3, val4, and val5 in the value column. It will help us understand the result of the triggers. Definitely the statement that we will do after insert and which is subject of launching the trigger is this update. We will discuss it a little later. Let's see that we don't have anything in the table test triggers. Oh, but we have. Okay, let me clear it. Now we don't have any data. We have here the insert statement. Now the insert was done. We do have the values 1, 2, 3, 4, 5, val1, val2, up to val5. Now let's do the update. What does this update? This update transforms the primary key, which is not an identity, because for many reasons it is not an identity, into some numbers which don't keep any, let's say, obvious reference to the previous values. 1 is transformed into 15, 2 into 9, 3 into 100, and so on and so forth. And we expect to have updates only for those IDs which are in the range 1 to 5. Let's execute it. We did. So the trigger has launched itself, and it appears that rows 1 val 1, 2 val 2 up to 5 val 5 were deleted. As a matter of fact, they were not deleted. They appeared in the deleted pseudo table just because these values were found previously, previously before the update was executed. Into inserted, which is the first one, we find the new values. 1 was changed by 15, 9 was changed by 2 was changed by 9, 3 was changed by 100, as we can see, because we have not changed the column value. Okay, so that's it. This is really bad. If we want to make logging, a sort of logging, and the primary key is subject to modifications, then with the data provided by the trigger, we will not know, unless we are fortunate, we will not know which row is which. So we have changed all the 5 rows, but only the column value that was not changed tells us which is which. Usually in practice, you cannot rely on something else than the primary key to identify the new values. So you will basically not know how to pair these results into a logging table. That's Microsoft. That's Microsoft. Okay, let's go now to Postgres. In Postgres, we have a similar trigger that only raises a notice for us, in fact, 2 notices, because you will see that ABC has its kind of value here, which tells us which old values are and which new values are. Okay, let's check that we don't have anything in the table. Again, F5, yes, we don't have. Let's insert the data. Yes, we inserted. Let's check it. We have it as previously in Microsoft SQL Server. And let's do the update. The update is the same update, as you can see here. So we do have ABC, which is a kind of control, let's say. Old ID is 1, new ID is 15. Old ID is 2, new ID is 9. Old ID is 3, new ID is 100. Old ID is 4, new ID is 7. Old ID is 5, new ID is 22. This happens because in Microsoft SQL Server we have only one type of trigger when we are speaking about data manipulation triggers, DML triggers. This is statement level trigger. The statement level trigger, which fires once, we do have these pseudo tables inserted and deleted that capture the values previously the modification and after modification. Inserted is after, deleted is before the modification. On Postgres, we do have this distinction. We do have triggers at the statement level which fire once, but they don't have access to the rows modified by the statement. And row level triggers, as you can see here, it's for each row trigger, not for statement, it's for each row, but it captures accurately exactly the modifications which were done and can be put safely into a logging table. Well, this is it. Let's try to execute again this. What will happen? Normally nothing, because we don't have any more IDs in the range 1 and 5. We don't have any more IDs in the range 9 and 5. And indeed, as you can see, this is empty, inserted is empty, deleted is empty, because the statement was executed, but it modified no rows, because no row was satisfying the condition about ID to be in the range 1 and 5. Okay, now let's go to Postgres and try this once again. Let me clear the output to be perfectly obvious and execute F5, 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 launch, launch, launch. Nothing, nothing. No rows were modified, so for each row was not executed at all. The behavior of Microsoft SQL Server may put some problems. What do you do? What do you do in the case you want to put a logging, but you find no data in both tables, inserted and deleted, pseudo tables? Okay, what do? You need to put an if in the trigger itself to detect this kind of undesired behavior, because it might produce errors, as it happened to me recently. What will happen in Postgres? Nothing, because no rows was modified, and the trigger provided no execution and no data. So this is even safer. See you next time, when we will discuss about error trapping inside the triggers in both Postgres and Microsoft SQL Server. Again, Postgres and Oracle have a very similar behavior, so I wouldn't provide an example for Oracle as well. Thank you so much. See you next time. Bye.